most of this new research seems to actually suggest the same. All of the information gathered about the surface of this comet seems to be fundamentally altered, or basically overwritten by billions of years of exposure to the galaxy itself, and the stuff we're seeing being emitted is not ancient material from the star system itself. And this is not just an interesting discovery, this is a very important paradigm shift. It basically suggests that many interstellar objects like this one have been dramatically altered by the radiation from outer space, the cosmic rays, and do not really show us the true picture of the original star system. And so even though astronomers were hoping that the analysis of this comet would actually tell us about what kind of star system it might be, which might even help us discover where it's located, what they seem to have discovered instead is that this is unlike any other comet we've seen. Here, the spectroscopy, which focuses on analyzing the light, specifically focusing on the SPHERE-X mission and the observations from the James Webb, pretty much definitively confirmed that the material that's coming from here has been pretty bizarre. But exactly what does this mean? Well, first of all, the amount of different molecules that was detected was entirely different from what scientists expected to find. For example, one of the first discoveries was the extreme enrichment in carbon dioxide. As a matter of fact, when comparing the emissions of carbon dioxide to water, for this comet, the ratio was 7.6, basically 7.6 times as much CO2 as H2O. But why is this a major discovery? Well, because in a solar system, we never see these ratios. In a solar system, the ratio is practically the opposite. It's something like 0.12, which means that comets use way more water compared to CO2. And this means that this is, for some reason, the most carbon dioxide enriched object ever recorded. But it's not just CO2, it's also carbon monoxide, CO. Here the ratio is not as high, only 1.6, but still higher than expected. And so because of this unusual dual enrichment in carbon monoxide and carbon dioxide, at first it made absolutely no sense because we don't really expect to see this from any star system anywhere out there. We don't expect any planetary disk out there to contain anything similar. On top of this, the comet was also ridiculously red. In essence, some of the more recent observations that tried to analyze the color spectrum discovered that it seemed to have a very specific red spectral slope, making it one of the reddest small bodies known to us. Now, because we've seen something very similar in the outer solar system, and because we generally know how this forms, scientists were then able to create models and explain these anomalous properties as a result of a major transformation by GCRs, galactic cosmic rays. Or just to rephrase this, extremely high energy particles constantly striking this comet for billions of years, very likely converted carbon monoxide into carbon dioxide, and actually created this relatively thick layer of approximately 10 to 15 meters that's entirely different from what it used to be when the comet just formed. And this was then confirmed by various lab experiments when researchers tried to replicate galactic cosmic rays striking ice and discovered that it was also turning red over time. In this case, it turns red because of very specific organic molecules. And so with time, the synthesis of these very complex organic-rich crusts covers this whole object with this very red and super thick crust. And in some sense, it kind of starts resembling a very dark red walnut. But crucially, the recent calculations of the comet's erosion during the passage through the inner solar system show us that the material lost before it reached the closest point to the sun only involved approximately 1 meter. And that means that everything we observed so far originated predominantly from this galactic cosmic ray processed crust. So essentially, we have not seen any pristine material yet, and may not even see it unless for some reason the comet breaks apart and reveals what's inside. And for astronomers studying comets, this is profound. It means that the effects of this very long journey basically tell us about the chemical reactions across the galaxy and not the pristine ices from the birth of a star system. So essentially, this is a really good example of what happens to objects if they travel through space for a long time, but just does not tell us much about other star systems. But at least we got some really good pictures from a lot of different probes. For example, here's a recent picture from the Tianwen-1 mission by China from a distance of about 29 million kilometers. And here's one of the more recent pictures released by NASA, captured by the NASA's Mars Reconnaissance Orbiter, that shows us both the trajectory of the comet and tells us a little bit more about the size of the coma. And in this image, we see something entirely different. Here we see hydrogen atoms from 3 different sources that were captured by the MAVEN spacecraft back in September of 2025. And here we're actually looking at ultraviolet emissions, but as you can see, one of the emissions is coming from Mars. And so it's actually 3 separate things.